Hi guys, welcome to the implementation part of this course. That is the part where we'll build the chatbot from scratch and of course following a step-by-step approach. This is Adlan here, the second instructor of this course, and I'm super excited to be back in the game. We will build a super powerful chatbot by implementing a state-of-the-art deep NLP model, which will be the sec-to-sec, and we will implement that with one of the best APIs to build deep learning applications or artificial intelligence, which will be TensorFlow. I hesitated to implement the chatbot in TensorFlow or PyTorch. I actually experimented with both, but I actually got better results with TensorFlow. And besides, I know a lot of you asked for some TensorFlow implementation, so I'm very happy to give that to you in this course. We will get into the details and the high-level techniques of TensorFlow to build our chatbot. So, this implementation will be done in 5 parts, which are the common 5 parts when implementing a deep learning application or an AI. So here we go. First part, part 0, installing Anaconda and getting the dataset. Anaconda is the IDE we will use to build our chatbot. We will actually use more precisely Spider inside Anaconda because it's like a studio and I want you to feel comfortable with all these great tools that Spider has when implementing our chatbot. And then we will get the dataset, which is the Cornell movie corpus dataset. Basically, it's a dataset of more than 600 movies containing thousands of conversations between lots of characters. And I wanted to train our chatbot on this dataset because I wanted to build a general chatbot that can have general conversations with us like a friend, instead of, a specified chatbot that is used for some specific purpose. That being said, the model we will use can be trained on other datasets for some other purposes. For example, you will be able to train the same chatbot on a more specific dataset like a calendar assistant or a navigation assistant. These are some more specific applications, but this is not what we'll do in this course. We will train a general chatbot to talk about everyday conversations. And that's why movies are perfect, because in movies you have a lot of random conversations, general conversations between friends, and so this will actually be pretty fun. Then part 1. So that was part 0, and part 1 will be data preprocessing. Data preprocessing is inevitable whenever you build an AI or whenever you build a machine learning model. You have to make the dataset compatible with the model you're going to build. We're going to build a neural network based model, and therefore the data will have to have a special format, especially for the inputs. Besides, we'll have to clean the text because the less we clean it and simplify it, the more difficult it will be for our model to train itself to talk like a human. So we will have to do a lot of data preprocessing. This will not be the funniest part, but I will try to do it the most efficiently so that we can get to the exciting parts, which are actually part 2, part 3, and part 4 when we get into the heart of the model. And speaking of these parts, part 2 will be building the sec-to-sec model, the sequence-to-sequence model, which is a state-of-the-art deep NLP model. So we will build it. We will actually build a brain composed of an encoder and then a decoder, and we will assemble all of them to build the final brain, which, be careful, will not be trained yet. And speaking of training, that leads us to part 3. Part 3 will be about training this sec-to-sec model, that is training this brain that we would have just made in part 2. So we will train it, we will set up a loss function, get the optimizer, and then apply some stochastic gradient descent to update the weights of the neurons of the brain so that it improves its ability to talk with us. And finally, part 4, the last part of this implementation, we will test our chatbot. That is, we will test the sec-to-sec model. That is, we will make some kind of a code to, once we execute it, have an interface where we can ask some questions and then the chatbot will answer. And we will just test the chatbot by observing its answers and see how it's capable of conversing with us. So this will be pretty exciting. And here we go, that's the plan of attack of this implementation. And without waiting, we're going to start with part 0 directly in the next tutorial. We will install efficiently Anaconda, and then in the next tutorial after that, we will get the dataset, and then we'll be good to go. We will start part 1 data preprocessing and the next parts after that. So I'm super excited to start. Let's install quickly Anaconda in the next tutorial, and I'll see you there. Until then, enjoy Deep NLP. Hi guys, and welcome to part 0, installing Anaconda and getting the dataset. So in this first tutorial, we will install the Anaconda IDE, which contains Spider, on which we will implement our chatbot. So just like me, go to Google right now and then type in the research bar Anaconda. Here it is. You take the first link, Anaconda Cloud, and then here you click on download Anaconda. All right, then you will end up on a new page, and on this page you need to find your system, Windows, macOS or Linux. I am on macOS, so I'm in the right tab, and you need to click on download here for Python 3.6 and not Python 2.7. So there we go, let's click on download. Then the download will not take long, just wait for it to be completed, and once it is the case, you are ready to install Anaconda. So the download will probably go to your download folder, so that's where I'm going to go right now. Here I am, that's the Anaconda installation file, so double click on it, and then very easy, you just need to click on continue, 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 agree, and install for me only, continue, and there we go, install, the installation is on its way. So it should take a couple of minutes, so I'll see you at the end of the installation. It will go without any issue. Perfect. The installation is done, so now just press close, and then if you want, you can move the installation file to the trash. So I'm going to do it. And there we go, Anaconda is now installed. And now we're almost ready. What we need to install is TensorFlow, because TensorFlow is not already integrated in Anaconda. However, I know that some of you work on a specific environment that you wouldn't want to interfere with this course. So what we're going to do is we're going to create a virtual environment. And besides, it's important to do it because TensorFlow has some issues with Python 3.6. So we're going to create a virtual environment with Python 3.5. So we're going to downgrade to Python 3.5. And inside this environment, we will install TensorFlow. So to do all this, we need to open either a terminal for Mac and Linux users or the Anaconda prompt for Windows users. So for Mac and Linux users, what you need to do is to open a terminal. So I'm on Mac here, so I'm going to open it from the Spotlight search, terminal, there we go. For Linux users, please open your terminal as well. And for Windows users, what you need to do is go to the bottom left corner of your screen, click on the Windows button here. Then in the list of programs, you have to find Anaconda. And inside Anaconda, you just need to find Anaconda prompt. And that's the equivalent to the terminal. So click on Anaconda prompt. This will open it. And then now we are on the same page. We are ready to enter some commands to create this virtual environment with Python 3.5, inside which we will install TensorFlow. So let's do this. To create a virtual environment in Anaconda, what we need to start with is conda. Then we add create, and then -n, and after that we need to give a name to this virtual environment, and so we will call it Chatbot. All right, Chatbot. And so inside this virtual environment, we want to install Python 3.5, so make sure to enter Python equals 3.5, and then Anaconda. That's to specify we want to create it in Anaconda, and then that's it. You just need to press enter. All right. So now it's going to take a while. It's going to install several packages with Python 3.5 inside Anaconda. So it should take a couple of minutes, as you can see. Here you just need to press Y for yes, enter, and now as you can see, it's installing all the different packages that you will need to implement the chatbot and execute different code. So it's going to take a while, so I'll see you once the installation is done. All right, perfect. Now the chatbot virtual environment is created. And so now what we're going to do is we're going to go inside this environment, we're going to activate it, and then inside of it, we will install TensorFlow. So to activate it, you need to use the activate command. However, for Mac and Linux users, you will need to start with source activate, and for Windows users, you will need to start with only activate. So for Mac and Linux users, you need to type here source activate, then you need to enter the name of the virtual environment, which is Chatbot, and that's it. And for Windows users, you need to just type activate without the source and then Chatbot. All right. So here, since I am on Mac, I need to start with source before activate, and there we go. Now you just need to press enter. All right. So now, as you can see, I am inside my virtual environment Chatbot. All right, perfect. So now I'm ready to install TensorFlow inside this virtual environment. And to do this, well, that's very simple. We need to enter pip, then install TensorFlow = 1.0.0. We are installing this specific version of TensorFlow that's important for our implementation. All right, and then you just need to press enter, and there we go. This will collect TensorFlow 1.0.0, downloading it, and then installing it inside the virtual environment that we called Chatbot. All right, perfect. Successfully installed TensorFlow 1.0.0. Great. Now you can just close the terminal, and now eventually we're ready to go inside Anaconda. So for Windows users, you can find Anaconda in the list of programs, and for Mac or Linux users, same. I'm going to use the shortcut here. I'm going to open from the Spotlight search, Anaconda Navigator. There we go. Found it. Anaconda is opening, and now I'm going to show you what you have to do. That's very important. This is now that we're going to connect to the virtual platform that we call Chatbot. And to find it, you need to go to Applications on here, then click on the arrow here, and you will find Chatbot. Chatbot, which is our virtual environment that we just created. And then you just need to click on Launch here, on Spider, the Spider window here, because this is the IDE in which we will implement our chatbot. This is for me the best, especially when you're beginning, because this is like a studio with many features, many cool tools, and everything at your disposal to implement a model, a deep learning application, or an AI. This is very practical. Then another one that I highly recommend is Jupyter Notebook, and that's especially if you want to add some LaTeX, if you want to write some mathematics, especially if you are writing a report. I wrote all my papers and research projects on Jupyter because I included some mathematics. But we won't include some mathematics here, so Spider will be perfect. So let's open our Studio Spider 3 inside the Chatbot virtual environment. Perfect. So now, welcome to Spider for those of you who are discovering it for the first time. So I'm going to quickly describe it. This is the editor. This is where we will implement the code. This is the console. This is where the code will be executed. So for example, in the end, when we test the chatbot, well, we will see the questions that we will enter here in the console and the chatbot answers as well. All right. And then here you have another window that welcomes three features. File Explorer, which contains all your files, so that's important, we'll see that in a second. Variable Explorer, which will contain all the variables that you create during the implementation, and help to get some help about the different objects we use or create. All right. So the first thing we're going to do now, and that's very important, is to get rid of this temp.py file by opening at the top. You click on File, a new file. So you open a new file, and then you get rid of this by clicking on Close tab here. All right. Then what you're going to do is you're going to go to File Explorer, and I recommend to create a new folder in Desktop. That's what I did. I created the Deep NLP A to Z folder. You can just call it Deep NLP if you want, or any other name. But that will be the folder that will contain the Python files that we will implement. Basically, that's the folder that will contain the chatbot. And also, very importantly, this folder will contain the dataset that we will download in the next tutorial. So let's open it. There is nothing inside because I'm starting from scratch with you. We're going to do the whole implementation from scratch together, and therefore that's why it's empty right now. So what we're going to do is save this new Python file that we just created, and we're going to call it chatbot.py. And this will be the file that will contain the whole implementation of the chatbot. The 4 parts of the chatbot, including how we build it, how we train it, and how we test it. All right. And so this file, chatbot.py, you will of course save it in your deep NLP A to Z folder that you just created. So that's why I'm going into it, deep NLP A to Z, and then you just need to click on save. All right, and there we go. Now you're ready to start. So we can remove all this. We can give a nice title to our file. We can call it building a chatbot with deep NLP. All right, you can click on save. And there we go. Now you're ready, like me, to start the implementation. Now your folder contains the chatbot.py file in which we will implement the whole model. And now what we need, of course, is the dataset on which we will train the chatbot. And that's what we'll get in the next tutorial. And until then, enjoy Deep NLP. Hi guys, welcome to this new tutorial. In the previous one, we installed Anaconda, TensorFlow, and our chatbot virtual environment. And in this new tutorial, we're going to get our dataset, which is the only thing missing right now. We already created our chatbot.py file in which we will implement the whole model, that is the whole chatbot. But to do this, we need a dataset to train this chatbot, and this is what we'll get in this tutorial. So this dataset is called the Cornell Movie Corpus dataset, and it's basically a dataset containing thousands of conversations from 600 plus movies between many characters. So let's have a look at this dataset. Let's enter here in Google Cornell Movie Dialogue Corpus. That's the one. Just press enter and just take the first link. So you just need to enter Cornell Movie Dialogue Corpus. Then take the first link. And there we go. That's the dataset. So let's have a look. As the description says, this corpus contains a large metadata, rich collection of fictional conversations extracted from raw movie scripts. So in total, 220,579 conversational exchanges between 10,000 pairs of movie characters. Not bad. Then it involves 9,035 characters from 617 movies, and in total 304,713 utterances. All right, perfect. So let's download it. To download it, you simply need to click on the zip file here, and this will start the download, which you should get in a matter of seconds. I just got it. So let's go to my download folder on my computer. Here we are, and here is the Cornell Movie Dialogues Corpus dataset. So let's double click on it to unzip it. And there we go, it contains several files. So now we have to make the difference between metadata and the real data. Metadata is like the data we will not use for the training. So it's things like the ratings or the movie it comes from, like some descriptional data. And we don't need that, of course. We just need, well, basically the conversations between the characters. And that's what we'll get now, and that's what we'll directly put in our deep NLP folder because we just want what's necessary for us. But feel free to have a look at the other files, like this one. You can see an interesting paper that will give you some relevant information. Then you have some metadata here about the movie characters. Then some other metadata here about the movie titles. Then some README script that will give you some more descriptions. But the things we'll need for our chatbot is actually just two files. These are the movieconversations.txt and the movie lines here. The rest we actually don't care because we actually won't use it for the training. However, let's have a look at these two files, movieconversations.txt and movielines.txt. Let's start with movie lines. So movie lines, as you can see, contains some extracts of scripts taken from movies. So for example, I'm going to open it with, let's see, Sublime Text, and let's have a look. So, as you can see, it contains several columns separated by these strings here, plus, dollar, plus. So that's the first column, second column, third column, fourth column, and fifth column. The first column is just an ID. It is the ID of the line said by some character in some specific movie. Then the second column, speaking of the character, is actually the character itself. U means user here. So, for example, if we take these first two lines here, that's a conversation between user 0 and user 2. Then the third column is the movie. So it is indexed by M and a number. So that's movie 0 here. Then the fourth column is the name of the actor, well, the character. And this is actually some metadata which we won't use to train our chatbot. And finally, the last column is the line. So what does this line mean? Well, it means that Bianca, who is indexed by user 0, in movie 0 says they do not. And then if we take the second line, well, that's taken from the same movie, movie 0, but this time it's user 2, named Cameron, that says they do too. And actually, the script goes this way. Cameron starts to say they do too, that's the input, and Bianca replies they do not. Okay? So that's an extract from a movie, movie 0, between two users, U0 and U2, Bianca and Cameron. And that's one conversation. And then we have other conversations with most of the time one input and one output, but not all the time. As you can see, for example, here we have a huge conversation starting from here, 860 to 862. So we have a long conversation here between Bianca and Cameron. Bianca, Cameron, Bianca, Cameron, Bianca, Cameron. Well, that's actually from the same movie with the same users, obviously, but a different extract from the movie. I don't know if you recognize the movie. I don't, but this is a conversation on which our chatbot will be trained. All right, so it's important for you to understand well the structure of the dataset. This is movielines.txt, which basically contains several conversations between some characters taken from different movies. All right, so we're going to close this now, and we're going to open the other interesting dataset, which is movieconversation.txt. So I'm going to open it with Sublime Text as well, and there we go. So as you can see, it's almost the same, except that this time we don't have the lines, we have the conversations. Each row of this dataset corresponds to one single conversation. So as you can see, in each conversation we have several lines, and these lines in one same conversation are all the lines composing the conversation. And this is important because the previous dataset didn't somehow separate the conversation, so we need this dataset to make sure we distinguish the different conversations on which our chatbot will be trained. All right, so let's close this, and therefore that's all we need. So what we're going to do now is take these two txt files, these two datasets. I'm going to copy them. I just copied them, Command-C or Control-C on Windows, and I'm going to go to my desktop where I created the deep NLP A to Z folder. So let's go inside and let's just paste the dataset composed of movieconversation.txt and movielines.txt. And congratulations, you have all you need to implement the chatbot. Just one chatbot.py file, which will contain the whole implementation of the chatbot, including how we build it, how we train it, and how we test it, and these two files which compose the dataset. That's it. So if you're ready, let's start from the next tutorial. And actually, in the next tutorial, we will start part 1, data preprocessing. This is not the funniest part, but let's try to make it with enthusiasm so that we can get to part 2 without even noticing. All right, so I'll see you in the next tutorial, and until then, enjoy Deep NLP. Hello and welcome to part 1, data preprocessing. Just before we start this part, we're going to import the libraries that we'll need to implement our chatbot. Good news, there are only 4 libraries that we'll need. First, NumPy to work with arrays. Then TensorFlow, of course, to do all the deep learning stuff. Then the RE library, which we'll use to clean the text and make them as simple as possible for our chatbot to learn in the best conditions. And the time library to measure the training time of each epoch. This will be interesting to see, to keep track of the training. All right, so let's import these libraries and then we'll be good to start part 1, data preprocessing. So let's start with the first one, the most classic one, NumPy. So to import a library with Python, we need to start with import. Then we enter the name of the library, which is NumPy here. And then we can give it a shortcut, especially if we're going to use it a lot. And for NumPy, we're going to give the classic shortcut NP. All right. Then, of course, TensorFlow, import TensorFlow as TF. We're going to use TensorFlow a lot, so the shortcut TF will be very useful. Then, as we said, we're going to import also the RE library that will be used to clean the text and especially to replace some characters by some more simple characters to simplify the conversations as much as possible. And eventually, we are going to import the time library to measure the training time. All right, perfect. And now we're going to make sure that you have everything installed correctly. And to do this, you're going to select these 4 lines of code here and then execute. To execute, the trick is to press Command on Mac or Control if you're on Windows or Linux, plus Enter. And then you can see in the console that the libraries were imported correctly. If they're not imported correctly, you'll get an error. So make sure you get this. If you get this, that means that everything was installed properly. And for those of you who skipped the Anaconda installation tutorial, make sure to have a look at it because we create a virtual environment inside which we install TensorFlow. So make sure we're on the same page here. And if that's the case, well, congratulations. You are ready to start part 1 data preprocessing. So we'll start in the next tutorial, and until then, enjoy DeepNLP. Hello and welcome to this new tutorial. Alright, so to start our data preprocessing journey, we have to start by importing the dataset, of course, because we got the dataset from the website, but it is still not in Python right now. We need to load it, we need to import it. And to do this, we're gonna use the open function. We could use Panda, but the open function will be okay, and we will load both the conversations and the lines. So we're going to give 2 variable names for our 2 datasets. We're going to call the dataset of the lines, lines, and the dataset of the conversations, conversations, so that everything is crystal clear. All right, so let's start with the lines. As we said, we give a name to this dataset, which is lines here, lines equal, and as we said, we use the open function to open this dataset, to load this dataset. And so to load it, well, that's very simple. We start by entering the name in quotes of the dataset, which is movie underscore lines.txt. And then we need to add several other arguments. I started to import it this way directly, but it didn't work due to an encoding issue. Therefore, to avoid this encoding issue, you just need to input here encoding equals, in quote, UTF-8. Then we need to import another argument. We can ignore the little errors, and to do this, we can input here errors equals, in quote, ignore. And that's it for the arguments. Then we simply need to add here dot read. That's actually to read the dataset when we load it. And eventually, we are going to add dot split parenthesis backslash n to split the observations by the lines of the dataset. And this slash n has to be in quotes. All right? And this line imports the dataset correctly. We will check that right afterwards, but I'm just going to do the same for our conversations. So I'm copying the first line, pasting it here, then replacing lines here by conversations. And here we need to replace movie lines by, of course, movie conversations. And there we go. We are ready also to import the conversations. All right, let's give it a go. So I'm going to select these 2 lines here and press Command or Control plus Enter to execute. And here we go. Well executed. As you can see, our lines and conversations were well imported. Let's have a look in Variable Explorer to see what they look like. So let's open lines first. So yeah, we got a warning here because it's a huge data set. So you can take the risk to open it. I'm going to take the risk and click yes. Let's see how it goes. Perfect. Nothing, not too much trouble. And so here are the lines. All right. So they are separated by the rows. That thanks to the split slash n. And well, it's like what we saw in the original dataset before it was imported here. You know, we have each row corresponding to one line, not a conversation, but one line, said by a character, for example here Cameron, which is user number 2, in a specific movie, movie 0, and the line is, she okay? an important thing to understand, this line has a key identifier, which is L984. That's a unique key identifier. We even got the type here, which is a string, of course. All right, perfect. So I'm going to close this by just pressing OK. And now we're going to open the conversations. We might get another warning or just some time to wait. All right, conversations, perfect. So let's have a look just to make sure you got this right. So each row corresponds to one conversation in a specific movie, movie 0 here, between two characters, user 0 and user 2 here. And as you can see, it doesn't display the conversation in text, but it gives the conversation by just giving the key identifiers of the line. So for example, this conversation here is composed of 4 lines. It's a conversation of 4 sentences exchanged between two characters. The first one is L194, then the second one, which is the reply by user 2 to user 0, I suppose, is L195. Then user 0 replies L196, and eventually user 2 replies L197. All right, and these are all the conversations we have in the whole corpus, Cornell movie corpus dialogue dataset. Perfect. So we got our dataset, and now we're ready to move on to the next step, which is to make a dictionary that will map each line's ID with its text. We already have a mapping between the key identifiers and the lines, but we want to make a Python dictionary because we will use it afterwards to get our data ready for the future neural network that we're going to build. So let's do this in the next tutorial, and until then, enjoy DeepNLP. Hello and welcome to this new tutorial. In the previous tutorial, we imported the dataset. We now have the lines and the conversations in 2 separate datasets that we called conversations and lines. And now what we have to do is to create a dictionary that maps each line with its ID. So why do we have to do that? What is the purpose of doing this? Well, first of all, one of the best advice that I can give you for coding is to always understand where you come from and where you want to go. So we come from the previous tutorial where we imported the dataset, and now we need to understand where we want to go. And where we want to go, what we want to obtain in the end, is a dataset that contains basically 2 columns, the input and the output. Because the inputs will be the inputs that will be fed into the neural network, and the outputs will be the target. Because we will compare the target, that is the real reply replied by the characters, to the answer replied by the chatbot. And that's how the chatbot will learn to speak, whether its prediction is close to the target. So where we want to go is towards a dataset composed of input and output. And the way to do that, the easiest way to do this, is with the dictionaries, because we will have to keep track of the conversations to make a correct mapping between the inputs and the outputs. And by the way, this is a first dictionary that we're creating, but you're going to see that we will create many others. And besides knowing that we want to obtain such a structure, well, keep in mind that we will have to do a lot of cleaning, because in order for the training to go smoothly, well, the texts have to be as much cleaned as possible. They need to be simple, simplified as much as possible, and you will see that we will have some cleaning sub-phases in this data preprocessing phase. So that's why right now we need to first create a dictionary that will map each line with its ID, and let's start doing this right now in this tutorial. So to initialize or introduce a dictionary, we need to start like this. We need to first give it a name, and we're going to give it the following name. We want to map each line with its ID, so the key identifier of the dictionary will be the ID of the line, and the value will be the line itself. So since we map from the ID to the line, the following name we're going to give to our dictionary will be ID to line. ID to line. And to initialize a dictionary, you need to do it this way by introducing a pair of brackets, just like that. All right, so dictionary initialized. And now, the common thing that happened afterwards, after initializing, is naturally a for loop, because we're going to iterate through all the lines of our lines dataset. And for each of these lines, we're going to split first the line, because it is separated by the plus 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 dollar plus plus plus. We're going to split that into the different elements of the row, and then we will get the key, which is the first element, and then we will get the value, that is the line itself, which is the last element. You know, if I open this again, well, this is what we will split, the value here, and the first element is this one, the ID, that we will map to the last element, which is this one. They do not. Okay, so let's do this. Let's start this for loop. So to start for loop, we start with for, of course. Then we need to give the loop variable, which we will call line, because we are iterating through the lines. So for line in, well, in lines, because our lines are in our lines data set. Then colon, and then we enter the loop. So first, remember what we want to do. We want to, if I open this again, we want to split this, because we want to get this and this. So we want to split this whole value here, and we're going to split this by this string here, plus 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 dollar plus plus plus. And the way to do this is to first take the line, and I'm going to add an underscore here first, and that just means a temporary variable because it will actually not be used later. It's like a local variable that is only going to be used in the loop. So underscore line equals, and this is where I'm going to make the split. So I'm going to take my line, which is the loop variable, line dot split parenthesis, and then in the parenthesis we need to input what do we want to split by, and we want to split by the plus 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 dollar plus plus plus. So in quote, I'm going to add space plus 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 dollar plus plus plus. There's a space because if you look closer, well, there is actually some spaces between the elements and this string here, plus 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 dollar plus plus plus. All right, so be careful with that. So that makes the split, and then we're going to get what we want, that is the line ID and the line itself, that is the text. But just for safety purpose, we're going to make sure that the line has the correct length, which should be 5. You know, if we open this again, well, each line should have 5 elements, 1, 2, 3, 4, and 5. We just need to make sure of that, otherwise we will get some shifting issue, and that could be bad. So in order to avoid this shifting issue, it's better to only get the IDs and the lines for the lines that have for sure 5 elements. And it's okay if we lose some lines. So let's press OK. And so, as we said, if the length of the line, the temporary local variable line, is equal to 5, well, what do? We're going to get the key identifier, which is the line ID, and the value, which is the line itself, the line set by the character. And there is actually a trick to do that in one line. We simply need to take our dictionary that was introduced as ID to line, and then in brackets we can enter the key here, which is line 0, and then to get the value, but not only get the value but also to do the mapping at the same time, we simply need to add here equal the value itself, which is line, and which element of the line? Well, if we look at this again, you know, the key identifier is this, and the value is this. They do not, and that's the 0, 1, 2, 3, 4th element. And I'm counting from 0 because indexes in Python start at 0. So be careful, it's the 4th index and not the 5th index, and therefore here I'm entering 4. And that gives my dictionary, that creates my dictionary that maps each line ID with its text. So let's check that. Let's check if everything's okay, and let's have a look at our dictionary. So pressing Command and Control plus Enter to execute. There we go. Dictionary ID to line created. As you can see, it was recognized by Python directly as a dictionary. And if we double click on it, yes. If we double click on it, well, we get our dictionary with, in the first column here, the key identifier, as I told you. And in this column here, the value, which is the line itself set by the character. So for example, if we take this line here, well, the line is, you know, I can talk about that. That's the value of the dictionary. And it has the key identifier L 100,006. So there are a lot of lines, but There we go, we got our dictionary, that's perfect. And that will be very useful for us to then get this special structure of the dataset that I spoke of at the beginning of this tutorial. Perfect, so now we're ready to move on to the next step, which is to create a list of all the conversations with the IDs as we got in the conversations dataset. And we want to do that, of course, because we need to keep track of the conversations for the training data. So we'll see that in more details in the next tutorial, and until then, enjoy DeepNLP. Hi guys, and welcome to this new tutorial. In this one, after creating a dictionary that maps each of the lines with their IDs, we're going to create a list of all the conversations. So first, we must wonder, why do we need to do that? Well, we already have a list of the conversations, but we have a lot of metadata, and we want to only keep what's interesting for us, what we will use for the training. And what we'll only use for the training is actually this part on the right. That is the list of the conversations containing the line's IDs. And therefore, what we're simply going to get in this tutorial is a huge list containing all the conversations, but only keeping this part. So we're going to get a list of all these lists here containing the line's IDs. All right, so let's do this. It's going to be quite the same as what we did before. We first need to introduce a new list that we're going to call conversations. And to specify that we only want to keep the IDs, we're going to add here IDs. So this will be our list. And since this is a list, we don't introduce it as brackets, but as square brackets. And then start the for loop. So for here, then the loop variable. And since we're going to iterate through the conversations of the conversations dataset, well, let's call the loop variable conversation. Perfect. In conversations. But then, just a little trick here. The last row of the conversations dataset is an empty row, so we won't include it, and therefore we will take the whole conversations dataset except the last one. And to do this, the trick is to do colon -1, because -1 is actually the last row of conversations, and by taking the colon here, we take the range from the beginning to this last row, but since the upper bound of a range in Python is excluded, this will exclude the last row, that is the empty row. So that's perfect, and now we're ready to start the for loop. All right, so basically we just want to simplify the conversations in the conversations dataset. So what we'll do first is, as before, introduce a temporary variable that we will call underscore conversation. The underscore specifies that it is a temporary variable. Okay, so this will be equal to the result of cleaning the conversation. That is, we only want to keep the last part. And besides, since we will want this last part to be a list in a huge list of lists, each list being a conversation giving the line's IDs, well, we will need to remove all the square brackets and all the quotes and all the spaces. And you will understand why soon. Okay, so first, let's get the last part. So just to make sure we understand, we first need to get this part here. So how are we going to do that? Well, very simply, what we need to do first is a split, to split all the elements here. Then once we make the split, we will play with the index to get the last element after the split, which is this guy here. And then once we get this last element, that's where we will remove the square brackets by playing with the indexes. And then again, we will remove all the quotes and all the spaces. Okay, so let's do this. Conversation equals, so as before, we take our conversation, which is our loop variable, but representing each of the different conversations. Then we add the split. And again, we're going to split that by space plus 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 dollar plus 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 space. All right, so with this, we make the split. But then we need to get the last element after the split, which is this one. And so how are we going to get it? Well, we're simply going to take the last index of this list resulting after the split. And the last index, we can get it with the trick -1. So that's exactly what we're going to do now. We're going to add here in square brackets -1, and that takes the last element. So if I go back to it, that takes exactly this, including the square brackets. But then remember, we want to remove the square brackets, because if we keep the square brackets, well, in the end, when we append this element to our huge conversations IDs list, which will be in the end the huge list of all the conversations given by the lines IDs, well, you'll get a nasty result with many square brackets and many quotes. So we want to remove this. We need actually to only keep the line IDs without the quotes and without the square brackets. So first what we have to do is remove the square brackets, and to do this, well, that's very simple. We need to take the range of all the characters here, but without the first index, because the first index corresponds to this first square bracket, and without the last index, because the last index corresponds to this last square bracket. So let's do this. I'm adding here this range that I just mentioned, which will not include the first index, that is the index 0, so we'll start from index 1, and which will not include either the last index, which is index -1. And that's perfect because the upper bound in Python is excluded. So that doesn't take the first index, 0, and that doesn't take the last index, -1. Great. So by doing this, we just removed the square brackets. And now we have to remove the quote, and then we will remove eventually the spaces. So let's first remove the quotes. The trick to do that is to use the replace function and actually to replace the quotes by nothing. That will just remove them. So let's do it. Let's use the replace function, which takes 2 arguments. The first argument is what we want to replace. So we want to replace the quote, the single quote, but that we have to put in double quotes. And the second argument is what we want to replace this first argument by, and that is nothing. But we need to put the nothing in double quotes, like that. So we're replacing the single quote by nothing, so we're removing it. Perfect? So that removes the single quote, but then remember we also want to remove the spaces, and so we're going to use the same trick, another replace, and we're going to replace this time the space by, again, nothing. And this will simplify everything. We will get, in the end, only the L194 up to L197 without any quotes and without any spaces and without any square brackets, just with the comma. And we need to keep the comma because then we're going to make another split to get these elements L194 up to L197. And why do we want to get these elements? Because that's what we want to put in each of the final lists of the huge list of the conversations. All right? The best way to be convinced about what we're doing is to try to do this without this part actually, without all this part, that is, as what we did here. Try to execute that for loop when we finish it at the end of this tutorial without this part, and you'll see that you'll get a nasty list with too many square brackets and too many quotes, and this will be ugly. Not only this will be ugly, but also this will be syntactically incorrect. So that's why we are doing this right now. And now the last thing that we need to do is just to append this cleaned temporary conversation to the whole list, the huge list of all the conversations. So that's why right now I'm taking this huge list, conversations underscore IDs, then dot, and then I use the append function to append this cleaned conversation. And therefore, in the append function, I just need to input underscore conversation. And then, as I just said, we use the split to get what we're interested in, that is the lines IDs. And to get them, we just need to split this last element here that was cleaned without the square brackets and without the quotes and without the spaces by the commas. So we'll only get this guy, this guy, this guy, and this guy. All right, so let's split that by the comma. All right, so now let's look at the result of what we just did. So I'm going to select these 4 lines of code here and execute. Perfect. Executed properly. And now let's have a look at our conversations IDs list. And this is exactly what we wanted. We wanted a huge list of all the conversations given by only the lines IDs. And so what I was telling you is try to get that huge list of conversations without what we did here, without taking the ranges here and without the replace. Well, you will get a nasty and ugly huge list of conversations with many square brackets and too many quotes. And that will be ugly and not correct. This is not what we want. We want a simple, huge list of lists, each list containing the lines IDs. Perfect. Now we're ready to move on to the next step. And the next step will be very interesting because we're going to get a lot closer to the final structure, because that's where we'll start to sort the lines into some questions, which will be the inputs of the neural network, and the answers, which will be the targets of the neural network. So we're getting closer and closer to the neural network, but keep in mind that we are unfortunately still in the data preprocessing phase. So let's do that in the next tutorial, and until then, enjoy DeepNLP. Hi guys, and welcome to this new tutorial. In this one, we're gonna get separately the questions and the answers. So, as we explained in the previous tutorial, these are gonna be respectively the input and the target of the neural network. That is, the questions will be the input and the answers will be the target. And so we're gonna get them separately before cleaning all of them, all the questions and all the answers. So that's the last step before starting all the cleaning process to make the dataset as simple as possible. All right, so let's do this. And before we start, well, it's important to understand where we're going to get separately these questions and these answers and how are we going to put them together. Because what we want to get is two separate huge lists, one for the questions and one for the answers, but of the same size. Because for each index I of these lists, well, the answer of index I should be the answer to the question of index I. Therefore, it should be well aligned. And to make sure this is well aligned, what we need to understand here is that in our conversations IDs huge list that we just made in the previous tutorial, well, in each conversation, the first element will be the question, the first question, the second element will be the answer. So basically, the key identifier of the answer is the next key identifier of the question just before. So that's what we need to make clear. And if that's the case, well, it will be easy for you to understand how we get these questions and answers. So let's do this. Since we're going to make two separate lists, one for the questions and one for the answers, we're going to introduce here two lists that we're going to initialize as empty lists. And of course, we're going to call them very simply questions and answers. And so as we just said, we are going to initialize them as empty list, which, like before, is with a pair of square brackets. All right, so our two lists are now initialized, and now we're going to make them with, of course, a for loop. So, for, and now according to you, on which object, on which list are we going to iterate on? Well, that's of course what I've just showed you, the conversations IDs. Because the conversation IDs not only contains all the conversations, but mostly it contains the key identifiers of each line of the conversation. So we will get the key identifiers in each conversation, and using our dictionary that we made before, we will get the text of the line. Because we no longer want to get the key now, we want to get the real text, because this will be the input and the targets of the neural network. So we want to get the real text, and therefore we have to use our dictionary to map the key identifiers to these texts. But to make sure we get well aligned by taking the answer as the next key identifier of the question, we need to use this conversation IDs list, because this is where we get the conversations. Therefore, we're going to iterate on this conversations IDs list. So let's do it. And therefore, we need to choose a name for the loop variable. We're going to call it, well, conversation. This is still a conversation, only it just contains the lines IDs. So for conversation in, as we said, conversations underscore IDs. All right, colon, and let's start the loop. Okay, so now according to you, and actually I recommend you to do that while doing the course, is to guess what I'm going to type. You know what we want to get. We want to get separately the questions and the answers. So try sometime to make pause on the tutorial and try to guess what I'm going to type next. So right now we want to get separately the questions and the answers. Then first, we know that in conversations IDs, the key identifier of the answer comes right after the one of the question. And besides, we have this ID2line dictionary that can map these key identifiers to the real text of the questions and the answers. So we need to use them both. And therefore, what do we need to do? Well, not only we need to iterate again on each of these conversations, because right now we're dealing with a specific conversation in all the conversations IDs. So we need to iterate through all the key identifiers of this conversation. And then once it is done, we will map these key identifiers to the real text. And therefore, what we need to do now is a second for loop. We need to iterate on the key identifiers of the conversation we're dealing with right now. And therefore, the second for loop is going to be for I in range of, well, basically we need to put the number of elements of that conversation we're dealing with right now. And this we can get it with the length that we can get with the len function of this conversation we're dealing with right now. Len conversation. However, since we're also going to get the answer in this second loop, well, we're going to add here a -1 because, we will take the index plus 1. We will take the I plus 1 here, and therefore it shouldn't go beyond the upper bound of the range. Therefore, the -1 here. All right, so with this second loop, we iterate on all the elements of the conversations, that is, all the key identifiers one after the other. And so, colon again, and now let's enter this second loop. And the good news is that right now we are ready to get our questions and our answers. And of course, since we already initialized them as empty lists, well, we simply need to use the append function to append what we have to append in, respectively, the questions and the answers. So let's start with the questions. Questions.append. And now try to guess what we need to append exactly. Well, remember, we want the text this time. We're getting closer and closer to the neural network, so we have to get the text someday. And so you know what to do. We need to use our dictionary, ID2line, because this is the one that maps these key identifiers that we're about to get to the text of the lines. And so here we go. Let's take our dictionary, ID2line, and in square brackets, we need to input the key identifier of the line, which is going to be, well, conversation of index I, because I is the loop variable that goes through all the elements of the conversation here, which is one of the conversation in the whole list of all the conversations. Perfect. So by doing this, we just appended a new question. And now we have to append the answer corresponding to that question. And therefore, well, let's maybe take this, copy, and paste it here because it's going to be almost the same. We're going to take care of the answers now. So I'm taking my answers list, and now it's going to be the same. We have to append the answer to the answers list, but remember that everything has to be aligned. At a specific index, the answer of that index should be the answer to the question of that same index. And as we just explained, the answer has the next index after the one of the question. This index corresponds to the index of this first element here, so that's 0, for example. And therefore, the index of the answer that we want to get, that we want to append now, and that should be aligned with our previous question, must be the next index, that is the index here, and therefore it should be I plus 1. And so, the only thing that we need to replace here is just this I by I plus 1. And that's it. We just appended the proper answer to our previous question. So now we're going to have a look. We're going to check if everything's okay. We're going to be able to check that by checking the relevance of the questions and the answers. So let's do this. Let's execute now. And there we go. Well executed. Now let's have a look at first the questions. Yes. And the answers. Yes. All right. And now let's check if our questions are well aligned with our answers. So let's take, for example, this one. How do you get your hair to look like that? That's the question. And the answer is Eber's deep conditioner every 2 days. And I never ever use a whatever. So that looks correct. Then let's take another example. I can see some French here. C'est ma tête. This is my head. So this is my head is a translation of c'est ma tête. And the answer is, so same index, 10, 10. Right, see, you're ready for the quiz. I suppose this is a French quiz. I don't recognize any movies in these lines, but it indeed looks like some movie lines. And anyway, we aligned correctly our questions and our answers, so congratulations, you're getting closer and closer to the right structure we're trying to get. And so now actually we can start cleaning all these texts, because as you can see, these will be difficult for the chatbot to train how to talk like a human, because we need to do a lot of cleaning. For example, I don't, we will replace that by I do not, so that all the don't, do not are associated with one same common token. And same for your, we're going to replace that by you are, and that is. Anyway, we're going to do a lot of cleaning like that, and we're going to put everything in lowercase as well, and that starts from the next tutorial. Until then, enjoy Deep NLP. Hello and welcome to this new tutorial. Alright, so we actually made a good step yesterday by getting separately the questions and the answers, because basically now we're ready to proceed to the cleaning process, where we clean all the texts of the questions and the answers. And by that I mean that first we're going to put everything in lowercase, then we're going to remove all the apostrophes, so that, for example, that is the same as that is when the chatbot is trained, and then we'll do some more cleaning by removing the non-important words, but that will be later on. Today we're going to make a function that we're going to call clean text, and that will be applied on a text, like a specific question or a specific answer, and that will do multiple cleaning at the same time. So we're just going to make that function today, and then in the next tutorials we will apply this function on the questions, all the questions and all the answers. So here we go, let's make this function. To make a function in Python we need to start with def, that's define, then we need to give a name to that function. We're going to call it clean text, and this function is going to take only one argument, which is going to be text. So I'm just giving a name to this argument, but later on when we apply this function to the questions and the answers, this text will be, well, either questions or answers. Alright, so there we go. We are ready to start defining what this function has to do. And so, as I said at the beginning of this tutorial, the first thing this function is going to do is put all the text in lower cases. That will simplify things a lot already. And so, I'm going to take my text, because we're taking the text as input and we're going to modify it several times. So I'm taking my text, that's my new text, and now I'm going to take my previous text, that is the argument text, and I'm going to add dot lower and parentheses. This is a trick to put all the characters of the text in lower cases. And that's it. We're ready to move on to the next cleaning step. So the next cleaning steps are going to be about removing the apostrophes, mainly. So same, we're going to take our text. This will be our new text after this new cleaning step, and this will be equal to, well, that's now we're going to use the RE library that we imported, and that will do some replacements, which, for example, will remove the apostrophes. All right, so text, we take our RE library, then we add dot, and then we're going to use the sub function, which will do the replacement we want. So we need to start here with R, then right after that we need to put what we want to replace in double quotes. And so let's start by replacing I apostrophe M, I'm. I put lower cases, of course, because we already applied the lower function. And so we're going to replace I'm by, and that's our second argument, in quote, we're going to replace that by I am. This will be much more simple for the chatbot during the training. And then the third argument is, of course, in which text we have to replace that, and that's, of course, our text. The previous version of the text, that is this one here. This is the new one. I have to replace the I'm by the I am. Okay, and now it's going to be very easy. I'm just going to copy this because we're going to make some other replacements that are going to be the same in terms of syntax. So pasting that here. And now what? We're going to replace he's and she's. So we're going to replace the he's by he is and the she's by she is. So let's do it. I'm going to remove this, add here he's, and we're going to replace that by he is. All right. Then let's copy this again because I'm just going to do the she's now. So she's, she is. Okay, perfect. Now let's see. There's a lot of that's and that we can replace by that is. So let's take care of that. That's, we're going to replace that by that is. Okay, let's continue. So you see the spirit. You can actually add your own replacements after this tutorial if you think I missed some. So he's now what? What's? You know, there's a lot of what's in question. What's the problem? What's? And we're going to replace that by what is. Okay, now let's take that again because I'm going to remake the same kind of replacement with where's. Okay, so where's, and I'm going to replace that by where is. All right, then new kinds of replacement now. I'm going to replace all the apostrophe LL by space will. So to get the apostrophe and not to confuse it with the Python apostrophe syntax, I need to use a backslash here. So backslash, apostrophe, and LL. And that I will replace it by, be careful, space, will. Because he'll go will be replaced by he, space, will go. Okay, so then copy that because I'm going to make some same kind of replacement. For example, with the I've got, which I will replace by space have. Then same for the your, for example, so apostrophe RE, that I will replace by you are, so space are. Okay, then anything that has to do with the would, I'd go there, I would go there, so I replace the apostrophe D by space would. Then we can replace the want, and now we need to remove the backslash because we don't need it anymore. Want, that we will replace by will not, but be careful to remove the space. Will not. Then I'm actually going to copy this and paste that below because now I'm going to replace some kind of the same thing, can't, by cannot. All right, and then I'm going to make a last replacement, which will actually be removal. I'm going to replace all the non-necessary symbols. You'll see what they are, and actually, again, feel free to remove even more than what I'm removing. So, since it's a removal this time, I'm going to replace what I want to remove by nothing, as we did previously for, remember, this part. And so now I'm going to put in double quotes again, but in a list that I put in square brackets. Lists are always in square brackets and dictionaries in brackets. I'm going to put all these symbols that I want to remove, that is, that I want to replace by nothing. Okay, so this can be, for example, minus, parenthesis, double quotes that I have to put after backslash, not to confuse it with the Python double quote. Then this, slash, at, semicolon, colon, below, over, bracket, the two brackets, plus, equals, the tilde, the bar, what else? Dot, question mark, comma, and that's it. You can add some more if you want, but you have to put them in that list. I think this will be already a good cleaning process, and we're done. We are actually done with this function, and at the end we of course need to return the text that is now cleaned. Perfect! So the function is ready. I will improve it if necessary, but I will not make a new tutorial for that. I will just improve it directly on the code that I will share with you at the end of this adventure. So don't be surprised if you see more cleaning steps in that function. All right, so that's it for this tutorial. In the next one, we will apply this function to our questions and our answers so that we clean everything in the Cornell movie dialog corpus, and then we'll move on to the next steps, which will be to remove the non-important words so that our chatbot doesn't get overwhelmed in the training. Alright, so I'll see you in the next tutorial, and until then, enjoy DeepNLP. Hello and welcome to this new tutorial. After making the clean text function, we're going to apply it on all the questions and all the answers to effectively clean their text. So we're going to start, as you can see, with the questions in the first code section, and then we'll take care of the answers in the next code section. So let's start with the questions. So it's actually going to be very easy. We're going to make a new list that will contain all the cleaned questions, and therefore I'm going to introduce here this new variable that I'm going to call clean_questions, and that will be this new list of all the questions that will be cleaned by the clean text function. So we're going to initialize it as an empty list with the pair of square brackets, and then of course comes naturally a for loop. So for, and now try to guess what I'm going to type, try to make actually the whole tutorial without me. So, well, we just want to get our questions and clean them. So naturally, the loop variable is going to be question. That's arbitrary for you to choose, but we're going to take the questions in the loop and we're going to get them from our questions list that we created 2 tutorials ago. So we take our questions list that contains the non-cleaned version, and we're going to take each of the questions inside this questions list and clean them one by one. And so now we're ready to enter the for loop, and inside, well, simply what we're going to do is apply the clean text function that we made in the previous tutorial. We're going to clean the question that we're dealing with right now, the loop, and then, almost over, we are going to append this cleaned question, because this is what is returned by the clean text function. We're going to append this clean question to, naturally, our clean questions list. And there we go. For all the questions in the non-cleaned questions of the questions list, we're going to clean these questions and we're going to append them one by one to our clean questions list containing the cleaned questions. All right, and that's it. Well, that's basically over. We get our list of cleaned questions. And now we're going to do the same for the answers, and the good news is that it's going to be almost the same. We will basically need to replace questions by answers. So I'm pasting that here. I'm going to introduce a new name for the list of answers, which will be clean answers, naturally. And so for all the answer in answers, I'm going to clean these answers first, and I'm going to append them to my clean answers list. All right, perfect. So we're done with our 2 for loops to create the 2 new lists of cleaned questions and cleaned answers. All right, so now let's have a look. We're going to execute these 2 code sections here. Make sure to execute the clean text function before if it wasn't done. And now let's execute this. There we go. It takes a little time because it has to make this for loop over all the questions and all the answers, but here we go. Now they're ready, and so let's have a look. So we get our questions, answers, cleaned questions, and cleaned answers. So as you can see, can we make this quick? First, the capital C is now lowercase. Can we make this quick? The question mark was removed. Then same, everything in lower cases. Then as you can see, the dashes are gone here. And let's have a look at the answers. We'd start, we would start. Then the dashes are gone, and if you scroll down, you will actually see even more changes, like okay, dash dash, you're gonna, okay, no dash, you are gonna. Well, as you can see, they were cleaned properly. We can clean them even more. For example, we can even replace the apostrophe S by IS, but I wouldn't do this because let's go, I think it's fine to leave it as let's go. We could also remove the exclamation mark, but maybe that helps with the sentiment analysis, so I didn't want to remove it. But feel free to experiment. Natural language processing is a lot of experimenting. We are going to train our chatbot several times. We're going to tweak the parameters. We're going to try to improve it. And in the end, I will actually give you several chatbots with some pre-trained models and some saved weights for the neurons so that you can get the best one if you need it for your business or your personal project. But anyway, the data preprocessing phase is also an artist's job. All right, so that's it. Our questions are cleaned, our answers are cleaned. Now we're going to move on to the next step, which will be to remove the non-important words. That is the non-frequent words. You know that each word is going to have its own column, its own encoding, and therefore, if we keep all the words of the corpus, there are going to be hundreds of thousands of them, and it will be very difficult for the training to take place in a reasonable amount of time. So that's why we have to do it, and we'll do this from the next tutorial. Until then, enjoy Deep NLP.